mentioned, I was trained as an electrical engineer formally. I also had a master's degree in physics. And what became apparent to me near the end of my PhD is that the future of electronics was no longer going to be simply shrinking the transistor using conventional materials, but there was going to be true materials limitations. The first one was the interconnects, when they got very thin using aluminum, suffered from electromigration. And the transition from aluminum to copper allowed Moore's law to continue. It was then apparent that the silicon dioxide dielectric was going to become so thin that tunneling would become a problem, and therefore high-K hafnia dielectrics would become necessary. And so the future of electronics became a problem of material science. And so this, to me, seemed to be the place to go. If you really wanted to work on next-generation electronics, then material science was the place to go. And when I was on the faculty market, I had many offers from electrical engineering departments, but chose material science because of this belief that it was the future of the technology I cared most about. Yeah, so I think particularly for electronic materials, I think we're at the point where even the traditional transistor using new materials reaches some scaling limits. And consequently, architectures beyond conventional transistor digital electronics need to be contemplated. Two that we are thinking about in our lab include neuromorphic or brain-like computing. And if we're going to try to mimic the brain, then we are likely going to need different materials than conventional silicon technology to get the more sophisticated functionality of a biological system. The second problem or strategy you could take would be quantum computing. And that's a very recent addition to our lab, and I think a frontier problem for material science. There are many methods for quantum computing, all of which I think require innovations in materials. The one which has our attention at the moment is the superconducting qubit technology. This technology works. The quantum computers at IBM, Google, and Rigetti use superconducting qubit technology. But what limits the performance is the so-called coherence time, the time which you can hold the quantum state. And if you can increase the coherence time, you can do more computations before you lose that quantum information. So the Moore's law for quantum computing will not be the channel length of the transistor, but the increase of the coherence time. And if you look at what's limiting coherence time, it's almost certainly coming from materials defects, surfaces, interfaces. And so I would contend that the future of quantum computing is now centrally a material science problem. Yeah, when I think of your department, I think of world-class research strength and a large department. And I think that's something which is an issue with a lot of material science departments, particularly in the US, but I think many places in the world, that they tend to be smaller in size. And yet, if you think about the scope of problems that are faced in material science, just in electronic materials, I think you could keep a dozen faculty busy, let alone if you're going to take on problems in biomaterials and polymers, energy materials. You need a big department to go after these problems. And I think Seoul National has that. I mean, your department is about double the size of Northwestern Material Science and Engineering Department, which is already proportionally large for our engineering school. So that, I think, is the great strength of Seoul National. Plus the fact that I think the connection to industry is quite strong, and that allows you to work on frontier problems that can impact society. I mean, when I think about cutting-edge electronics, I think of Samsung, I think of cutting-edge battery technology, LG comes to mind. Seoul National is very well positioned to take their discoveries to the real world. I think universities definitely have a role to play with fundamental science and very long-range objectives that are not necessarily tied to short-term market opportunities. So I think universities will always play that role. I don't think that's a problem for universities. They've done that since their founding hundreds of years ago. The opportunity, though, I think, which is emerging, is to do that and impact the short-term market. And that makes what we do much more closely tied to society. A science or nature paper is of interest to academics, but not to everyday people. But a technology that impacts their lives, undoubtedly, is important for society. And I think universities have realized that they have the capacity to do both. It's not an either-or situation. And I think that's the opportunity that we all face, not just in the US, but here as well at Seoul National. Yeah, I think the advice I give to students is you have an opportunity, especially in a big department like Seoul National, to achieve great depth. Your PhD is going to be a deep dive into a topic, and you will have great depth. But at Seoul National, you can also have great breadth. Access to 43 faculty in diverse fields, to an array of speakers that are going to come through the department in very different disciplines than your specific thesis is the real opportunity. Can you understand, communicate effectively, draw inspiration from, and impact fields beyond your PhD thesis? Because the reality is, once your PhD is done, you're almost certainly going to be doing something different for your postdoc or your career. And over the course of your career, you're going to have to pivot many times. Learning how to do that as a PhD student is the real opportunity. And I think Seoul National is one of the best places in the world for that. Yeah, it's a challenge from a pedagogical perspective. But I think, to be honest with you, seminar series are one of the most effective ways of becoming conversant in other fields. And I always challenge graduate students to go to seminars in fields that are as different as possible from your PhD. You can always go to a seminar that's related to your PhD and get something out of it. But can you go to those seminars that are seemingly disparate from your PhD, get something out of it, and can you ask an intelligent question at those seminars? That's a challenge. You won't be able to do it on day one as a first-year graduate student, but if you go in there at least trying to think of intelligent questions, maybe going up to the speaker afterwards, then you will gain confidence that you can understand quickly what else is happening. You can have insights that are potentially relevant because your perspective is so different than someone who's embedded in the field, that you can draw inspiration for your own research from something that's seemingly disconnected. The most creative, and I would say brilliant, ideas are the ones that are not obvious to everyone in the field. And you get that by constantly thinking outside of your comfort zone. Well, I mean, in addition to the world-class faculty and students, which is, I think, what makes a great university, I mean, more superficially, one thing that I really like about Seoul National is that it's actually on a hill. Because I come from Chicago, where there's no hills whatsoever. I think the topography of Seoul National and the views that it provides are inspirational. So on that level, this is what I think of when I think of Seoul National, is a very beautiful, thought-provoking place, both in the classroom and just walking around campus. Yeah, so I think there's a couple components there. The first thing you mentioned was diversity, and I think diversity of background, diversity of perspective, of discipline, diversity in all aspects of the word are critical to creative brainstorming, innovative solutions. So that is something I'm a strong advocate for. And that would include cross-cultural collaborations, international collaborations. These are an opportunity to draw from very different perspectives on the world and on science and engineering particularly. So yeah, I'm a big fan of international collaborations. I'm directing the Materials Research Center at Northwestern, and we have over 100 international collaborations in the center touching all continents except Antarctica. We haven't gotten that one yet. And we're always open to more. So I think there's great opportunity for partnerships between Seoul National and Northwestern. It's been a fantastic visit to Seoul National University, a world-class institution from the faculty level to the graduate student level to the undergraduate student level. It's been a great pleasure visiting today. Thank you all for watching, and I wish you great luck and fortune in the future.